Hello class, this is a continuation of calculus. In this video we'll be looking at the power rule. So we've seen the foundational theory in calculating the derivative of a function and all the other concepts around it. We saw that the derivative could be calculated using this. So this is differentiation by first principles. I'm not going to recite it again. There are, however, and thankfully, far easier methods to calculate the derivative. I'm sure you'll all be excited to see this because it's much more easier than you think. So, the first method that we're going to learn is the power rule. Given a function f of x equals ax to the power of n, its derivative is simply a times the power, and then we subtract the power by 1. So let's do a few examples of this. Here we go. For this, we can find that the derivative f prime of x is equal to, so following the power rule. Now remember there's a coefficient of 1 here, so that's a. So we're going to take the coefficient and multiply it by the power. So this becomes 2x. And then we're going to subtract the power by 1. So 2 minus 1 is just 1, which is actually what we saw when we found the derivative of x squared. Let's do this again. Now here's some slightly new notation here. If we have the function g of x, its derivative is g prime of x. So following the power rule, it's going to be 2, the coefficient of x, times the power. So this becomes 6x. And then the power, we're going to subtract by 1. So 3 becomes 2. And this only works if it's a plus. So this is an entirely new term. So for this, we can find the derivative of this particular term. This is plus 5 times the power. It's 10. X 2. We're going to subtract by 1. So x to the power of 1, which we just leave as x. A lot easier than far easier than the first principles. So h prime of x. Again, taking the coefficient and multiplying by the power, well, this becomes negative 16 x. This one, well, 4 take away 1 is 3. For this, if you have just a x, remember there's a power of 1 here. So this becomes 2 times 1, so it becomes negative 2. But now if we take 1 minus 1, that's x to the power of 0. This becomes x to the power of 0. Well, x to the power of 0 is just 1. So really this is 2 times 1. So there's really no need to write it. So if you have a x with a power of 1, you just take the coefficient. Let's do a few more examples. If we have p of x, p prime of x, you can go ahead and pause the video at any time and give this a go yourself, because I want to start speeding up here. For this, it's going to become negative 8x to the power of 3. This becomes 9x squared. This becomes negative 8x to the power of 1. And now, if we have a constant, so this has x to the power of 0 already. Well, if you think about this as x to the power of 0, still following the rule, this will be 1 times 0. That's just plus 0, x to the power of negative 1. But this is 0 times something. Anything times 0 is 0, so it just goes away. So a good summary for that is constant values, so that doesn't have an x, they just disappear. A few more examples here. Q prime of x, getting a little bit more tricky. Half times 6, that becomes 3x to the power of 6 take away 1 is 5. So I already know it's going to be a negative. 3/5 times 5, that's going to be 15 over 5, which is negative 3. X to the power of 5 take away 1 is 4. Hope you remember, this is x to the power of 1, and this is just 1x. Whenever there's just 1x, the x just goes away. That's a nice way to think of it. And now we have a last one here. This is pi. This may seem confusing, but this still has x to the power of 0. Differentiating this, it becomes pi times 0, so 0, pi to the negative 1. Well, as we've seen before, that just goes away. Let's do slightly more difficult questions here. So let's find the derivatives here where we have to apply our different index laws. So before we can differentiate this, we need to, rearrange it so that it's x to the power of a half. The derivative of this then is f prime of x is equal to, remember there's a coefficient of 1 here, so 1 times a half is a half. X, so a half x. Half minus 1, you can test in your calculator. A half minus 1 is negative half. Reapplying some some index laws, this becomes 1 on 2x to the power of a positive half, which if we keep applying some log laws, this becomes, index laws, this becomes 1 over 2 square root x. For this, we can rearrange this to x to the power of negative 2. So the derivative g prime of x becomes negative 2x. Negative 2 minus 1 is negative 3. Rearranging this becomes negative 2 on x to the power of 3. Once again, rearranging this becomes x to the power of 2/3. The derivative h prime is equal to taking the coefficient and multiplying it, taking the power and multiplying it, becomes 2 on 3x 2/3 minus a 1, so minus 1. You can check in your calculator. This is going to become negative 1/3. Rearranging this, 2 on 3x to the power of a third, which we can write as 2 over 3, the cube root of x. These are again slightly more difficult. You can pause the video and give this a go yourself. So here we go. Rearranging this, it becomes, I'm going to skip a few steps here. It's going to become negative x to the power of 3 over 4, like so. The derivative of this becomes negative times negative 3/4 becomes a positive 3 over 4 x. Negative 3 over 4 minus 1 scared, you can check your calculator. I'll demonstrate it to you here. Oh. Negative 3 over 4 minus 1 as a fraction is negative 7 over 4. So this becomes, no, oh, there we go, don't freeze. So negative 7 over 4. Rearranging this becomes 3 over 4 to the power of x 7/4. Rearranging further, this becomes 3 over 4x to the power of 7 4th root. One last example. Let's rearrange all of these first before we differentiate. This becomes 3 to the power of x, 3x to the power of negative 3 minus x 3 over 2 plus x to the power of negative 4 on 5. And this one is just a nice 2x. Derivative of this now, q prime of x becomes negative 9x to the power of negative 4 minus 3 on 2 x to the power of a half minus, because remember we're taking the power and multiplying it, so it becomes negative 4 on 5 x. Even this one gets a little tricky. Negative 4/5, take away 1. Negative 9 over 5. And this one, I hope we're not getting lost in all the index laws. This is just following the basic rule, multiplying the power by the coefficient and subtracting by 1. So that's x to the power of 0, which just goes away. Rearranging all of these, this becomes negative 9 over x to the power of 4, negative 3 square root x on 2 minus 4 on 5, the 5th root of x to the power of 9 plus 2. So, even though these last few were a little bit tricky, I hope you saw how simple it is to find the derivative of any basic function of the form ax to the power of n. Hope to see you in the next video. Best of luck.